Okay. Hi. Here I am starting another live stream. And this live stream is also for coding. Um, and the point of this, just a sec, I'm still not used to this. Okay. So, hi. Oh. Here
What the
I
heck?
am starting. Okay. I guess it's working because I already had it open in another tab. So let's close that. Um, oh my gosh, there's three of me now. How do I get out of here? Where is this plane from? Must be my other screen. Oh man, I did this because I didn't want to share my screens. Oh, exit. Okay, good. Alright, now I can start. Okay, so, what is the point of this? The point of this is I want to make generative art, is what they call it. I have no experience with this, uh, really at all. I guess I have a little bit of experience with it. Um, I have, so first things first, I have this unique style of art, of drawing, uh, and this style I kind of made up. You can see it, I'm selling in my Etsy. Oh man, my Etsy is Pastel Pat, and I haven't sold anything. I guess I have to sign in. Oh, I don't want to sign in on here though. I don't know. I guess you can't see it. Okay. I don't know why I'm not coming up. Let's get this out of here. But if you go to my YouTube, you can see me. There's a couple clips of it, but basically, here you could see. Oh yeah, I guess I'll just play it. I guess you can't hear this. It's playing music in my headphones. But so basically, what this style is, I have a slower video version of it, and this style is you just kind of draw. It could be a curve. It's a curved kind of figure. It's defined. Each one is supposed to have two or three curves, and that's it. You kind of just draw the first one. It's a shape that you could, if you look at every shape closely, like, see here, this shape has two curves. You could even zoom in on this, or I guess, or yeah, so like you could see this shape has two curves, this shape has three curves, three curves, three curves, two curves, two curves, two curves, three curves. And this is just a style I invented on my own when I was in 5th grade, drawing in my notebook. So, and it's fun, there's different things you could do. This version, I play around with colors with it. Sometimes it looks bad, sometimes it looks cool. But what's truly magical about this style is the first drawing I ever did when I was in 5th grade. I just kept adding to it, and ended up looking like a turtle eventually, which is really weird. But if you could imagine a turtle in this style, that's very cool. And so my idea is, well, I could just make this over and over, generate it until cool things like turtles pop up, and in drawing these cool things pop up. The main other cool things, like I've drawn a bird before. Um, Things like the bird was the main cool one. A rose, sometimes roses have popped up. And so I think it would be cool to randomly generate some stuff until you start seeing something cool. Like say you see something that looks like a rose pop up, and then you could, generate 1,000 drawings. Oh yeah, that's right. So the main limitation is the drawing time it takes. If you want to draw one of these, it takes hours and hours. So even if you're pumping them out like crazy, you can maybe do one a day, and then it's a huge part of your life. And then you might end up with a few that look cool. if you could write some code that will generate this automatically, um, then you could like train a model to make some cool drawings or whatever. And I don't think this could be that complicated, because it's just two or three, uh, two or three curves per shape, and then you fill in the shape. And then there's some complicated stuff like you have to make sure the shapes are adjacent and are separated by about the same amount of white space. Or ideally in code version, just a sec, my dog's barking. Okay, so the idea is, if I could write some code, this doesn't seem too complicated, the process itself. So write some code. First step is write some code that will do it. So it's a simple rule. Each shape has two or three curves. You put two or three curves together, touch them, and that defines the shape. And then the shapes kind of like touch each other, or are separated by a constant amount of white space. Um, so hey, stop. I wanted to. So I guess the first thing to talk about is my experience with this. So my experience is in 2017. This is my website. Um, I also want to make a video on how to do a website. But in 2017, when I took my first coding class. I knew nothing about computers. Computers were magic, and in 2017 they stopped being magic. So I took my first coding class, um, and I learned Python. And so I have my final project from that class is on this site, Python final project. So this is from summer of 2017, over 5 years ago now. And I forgot what the assignment was for the final project. Uh, but I wrote this program. Oops, I have VS Code open in some other windows, so if I open it here, it won't work. Oh no, it's not open in here. Good. So, if I go to here, open PowerShell, CD, desktop, CD, personal stuff, projects. Oops. Well, one of the dogs keeps barking and no one will stop it, so I will be right back. Okay, so, um, okay, so now I'm making a new directory, art, I'm gonna call it generative art. This is my projects folder, so this is my new project. There's nothing in here. I haven't learned how to make a file in Windows, so I'm used to doing this in Linux, so I'll just do that part in Linux, in WSL, if it will load. Okay. Now I'm gonna go to the same location. Generative art, and then make the file final. Call it the same thing. Py final proj dot py. Don't even need just final proj dot py. Okay. Then minimize that. Then code final proj dot py. Okay. So now we're in the project. I just copied that code. Here we paste it in. I don't know what that means. Environment variable path seems to have some paths containing the parenthesis or the quotation character. Existence of such a character. Okay, I guess I will just ignore it. So final project.py. Why can't I copy paste? Did it not copy that code? Nice. Okay, so here it is. Now, oh, it copied the numbers too. So here it is, my famous file. File name, oh, it was originally called final.py. Author Patrick LaChapelle. Class Computer Science 131. Summer quarter 2017. Date created July 25th. Last modified August 16th. So this is my first real code I did on my own. Best of times. So, let's see, what do I want to do? What do I want to do? Oh, I just want to run this. This uses Turtle, which is a graphics thing. I have WSL1, which doesn't work with graphics. Apparently, they just came out with an update for WSL2 that makes it work well with graphics without having to do all these settings, because that gets so confusing on Linux. I guess they say the point of learning Linux really is you want to achieve all this functionality, but I think it will be nice to have with Windows because you kind of get the functionalities. You get to do things that are hard to do with Windows, but you don't really have to learn everything with Linux. That's what I like. That's what I think is great. But Linux, obviously, maybe I should learn that eventually because it's open source and stuff. Blah blah blah. So, this is my initial file. You can run it and oh yeah, PowerShell. Yeah, so Linux doesn't do graphics, so this uses Turtle, which is like a graphics thing. So I want to use PowerShell. So this is a big long code thing, but you can ignore what it is. Just look here. So I want to zoom in. So Python, and we're gonna run the file. Okay, what would you like to do? Please choose one. So I do these different things. Some of them don't work anymore. I forget why. But you could do. So these are the choices. So you could choose as your function name drawing. That's what I'm gonna do. My name is Pat. And what color do I want it to be? I want it to be green. What should the background be? Red. Enter width of line. I don't know, 10. And then it draws my name. Oh, I don't know what happened to the P. Oh, that's right. So I even handled that. Thank you. Have a nice day. Goodbye. Unable to read this character, please enter a lowercase alphabetical letter. So this is pretty low level stuff. It fails. It just tells you that it fails if it gets a capital letter. Now I know you can just do string.lower, call the lower method on any string. Welcome to the most optimal and sophisticated computer program mankind has ever created. um, anyway, this is cool. Recursive function is cool too. You could draw a spiral or a flower. Size 38, 39. Width 4. 3, I guess. Choose number of repetitions, 100. Red, blue. There it goes. Anyway, cool stuff. Very fun. And so this is Turtle, where you can kind of automate stuff. And so my thought is in Turtle, I could animate the drawing of some of this stuff. So that's what I'm up to now. I want to go into Turtle. So I haven't used Turtle since this project, other than a couple of false starts I've had at doing my current project. So we can go into, this is the NFL project, so we could just go out and then to the other projects. What the heck? Generative art, there it is. So we can do a new text file here for progress. Open it up. To-dos. Completed. And notes. Okay, so the first to do is animate one single element. I'll just call each little thing that I draw, each little shape I could call it. Animate one single, I like elements, one single element, one object, since it's Python and we're instantiating an object from a class. So the first step is actually animate one two-sided object. Animate, and before that, the goal is animate one curve. Okay, and so now the thing is, how do you do the curve? What does the curve look like? If you look carefully at what I was doing here, these curves are loose. They could be anything. They could go one way and curve back another way. Typically they only have one main curve to them, but every once in a while it looks good if you, I know I could do this in Paint. Do a new one. So most of the curves are kind of like that. That's a typical curve I do. I do some like this where they're both kind of bowing out, or that one's sort of straight, but sometimes it'll be like that. Sometimes they'll both be kind of bowing out, so it's almost like an ellipse or something like that, a pointy ellipse. But sometimes you could have a cool shape, like it kind of maybe goes out like that, and then comes back in like that, and then does that. As long as this isn't a point, as long as that's clearly a curve. Things like that. That's if it's three-sided. So, the challenge is you want to get a curve. You don't want it to be kind of a simple way to do a curve is you could do a circle. But that isn't how these are drawn. These aren't all circle curves. In fact, probably none of them are. None of these would fit onto it. Like, look at this one. This one's a good example. Very. This one, I guess it kind of looks elliptic. But I don't know. My hunch is that an ellipse is also too simple. Although I think that might work. I don't know why that couldn't work. Um, uh, so yeah, these are kind of irregular shaped, and doing something simple like draw part of a circle isn't gonna work. Draw part of an ellipse might work, but when I looked at that before, it was kind of confusing because you have to, find some random place where it makes sense to have focal points just to have an ellipse. So I feel like a parametric curve would make more sense. I was looking at parametric curves. I don't have that much experience with this, so it's kind of new. And I was playing around looking at it, and I found, I think they're called, well, they're spelled like Bezier curves. Bezier curves. I don't know. Let's see how to pronounce Bezier. Bezier. Um, Here we go. Oh, my earphones are off. I'll turn this on for your benefit.
Bezier.
Bezier. Oh, so it's French or something like that. So if we look up Bezier, oh yeah, so that's what I was looking at earlier, cubic Bezier curves. Uh, so when I looked at Bezier curves, they have different types. I wonder why isn't it letting me change around these values? Maybe we just need to go to the site and get rid of that part. So yeah, you start with this curve, but this kind of gives you what you want. But then the problem with this, it gives you what you want in some respects. So I'm trying to do it. I did it earlier. But I think it makes a loop if you do the wrong thing. No, this one might not make a loop. But anyway, that doesn't look good. That is too complicated. I don't have any shapes like that. There aren't any shapes like that. It might have a curve, but it'll be more subtle. Um, Oh, yeah, and this is all for, they use it, I guess, in web animations. Anytime you try to look up something that's Bezier with the web, it's just an animation thing. Um, but this is the curve, so I don't care about the animation, but I want to do the curve. Anyway, this one a little complicated. Oh, here it is. The quadratic one, though. Oh, you choose them here. So if you choose, I don't know which one this is. I guess just this website only has cubic ones. Well, that's interesting. So I guess I was looking at a different website that had the different curves. And I wanted a cubic one. Oh, that's just to compare it with the current one. Hmm. I guess I decided that would be fine. Maybe the rule is it has to be to one side. Well, that could be. I could define like a middle point and then be like, now they have to each be on the same side, maybe. They could be anywhere on this side. Any wacky shape you want to make. But they have to be some distance away from the line, should be the rule. I don't know, but that's a nice shape too. It should be able to make that every once in a while. So there's kind of two important things. When you draw the curve, Um, you want, so you could draw the first line. If you're just drawing one initial element on a blank piece of paper, it doesn't need to be flush or anything. You could draw anything. Start anywhere. Usually you'll probably start at the origin, but you can draw any line, draw any curve, go in any direction. So I'm gonna start a new file for notes because I'm just trying to think this out. So, and if I open that up, okay. Uh, sim first element, minimal rules, two sides. Here's what happens. So, first, there is a random curve drawn, random curve with no constraints is the number one thing we want to do. From there, the number two thing we want to do. So once we have that random curve, we need to make another random curve with the following constraints. And those constraints are A. I can make this bigger. Okay, random curve with the first element, minimal rules, two sides. Okay, first you do a random curve with no constraints, then you do a random curve with the following constraints. Okay, what's the first constraint? Endpoints must match with the endpoints of the first curve. Okay. And what else do we have? What's the other condition? Endpoints have to match up. Oh. Curve cannot overlap the first curve. So we could also phrase that as the second curve must intersect the first the second curve must intersect the first at the endpoints. The second curve must intersect the first only at the two endpoints. That's right. The second curve must intersect the first only at the two endpoints. Okay, so those are our two rules. So first, I want to animate a random curve with no constraints, and then I want to animate a random curve with the following constraints. Random, not just any random curve, a random quadratic Bezier. And here, not just any curve, or random, quadratic Bezier. Okay, so, where are we at now? I am ready to start using Turtle. So, Python, Turtle documentation. First, I'm going to open up the documentation. Then, gonna make a new file. I guess I could call this simple. I'll call this initial curve. I'll just dedicate one file to getting a single curve going. Okay. Oops. I'm in touch. Initial curve.py. Then pop over to PowerShell. I guess I exited out. Oops. So PowerShell. Just gonna go over to our directory, desktop, personal stuff, projects, man, what projects is this called again? Oh, generative art. And then code, initial curve.py. Okay. So, where is this at? I want to see how long this has been streaming. Oh, live. 32 minutes. Cool. Okay. So, now initial curve.py, import turtle as t. Okay. Yeah, so let's see. Let's see if it tells us how turtle draw quadratic Bezier. This program shows an example application. Turtle stitch. Does that mean it's in Python? What the hell? Wow. I didn't know this existed. So you could just plug them. Weird. Weird, man. Okay. Leave back. Oh, that's great. Draw a quadratic Bezier through 3 given points. I think that's just what I want. I have 3 points in 2D. P0, P1, and P2 be the control points, and PC be your fixed point you want the curve to pass through. Well, that's great. If I have 2 control points, then I just need to make sure the curves don't intersect. If you have a quadratic, let me think. Draw multiple quadratic Béziers. Yeah, so that's what I want. That's a quadratic Bezier. So if I have the constraint of these are the 2 points here, and then this has to be this can be inside of there. There's something to constrain it. But I'm having trouble thinking of what. So how do you find the outermost part of this curve? It's when the outermost part of the curve. Okay, so there must be a way to calculate that. I can calculate. I know that the outermost part of the curve happens when each is at 0.5. So you can, if you have these 3 points, you have the 2 endpoints and the control point, then you can calculate. Man, this is easy to do by hand and hard to do by on a computer. I guess I should see if there's a way to make a notebook stream. So there's a way to calculate that, but it's gonna be a big pain in the butt. But maybe it's necessary. So, oops, don't want to show all my docs. Okay, so here's a Google Doc. And here, oh. So we could set it up nicely. So we have the 3 points for the curve. We could set a bounding box, but it's not really a bounding box. I think okay, let me think. So this point has to be beyond. If there's 2 of these curves, and the first one is like that or something, and the second one is like that, maybe I bet I could draw one of these curves. So insert. Maybe there's this equation. Path D goes M100, 250, QC. I wonder what the hell that means. So I guess some of that stuff stays fixed, and then those 2 middle values change. So let's see if that's a thing now. Turtle, draw equation. How to use Python turtle to plot a function. I don't know, I figured this out at one point, but I forgot where I put it the first time I was trying to do this project. So, what I want to draw, Man, this is hard. So even if this is here, there should be a constraint that makes it can't be that close. It shouldn't be able to be in this range. It should have to be like here or something. So I could start out by just trying to make a version where each side is going out like that. That would be easy. Make sure two quadratic Beziers do not overlap. Okay. So to draw a quadratic Bezier, I feel like you could insert a shape here. Line, table drawing, image. Could be drawing. New. Curved connector. So that's not really what we want. Okay, good. So you can do the first one. First, I'm actually going to mark 3 points. So here's point 1. Here's point 2. Oops. I guess this should be bigger. But I'm just gonna put in a circle. I wish you could change the color. Oh, you can change the color. Okay, so here's the first endpoint. Oops. Damn it. Okay, there it is again. Tiny little circle. And I'm gonna make it red. Oops. I can Control Z that. Copy, paste. Man, that thing's hard to grab. Then I could put that on there. And finally, for the last one, we can make this one green. Okay, now we could do a curve starts there. Goes through there. Get rid of that curve because I messed it up. Starts here. Midpoint is there. And it ends up oh, but that's not if you draw the far away point. That's if you draw the point that it intersects. So, I wonder if I can do that. I say how if a program that does it, so obviously you can. And then I could just say, okay, so that's what I really want. Draw Bezier curve. Draw quadratic Bezier with endpoints and a point on the line. Bezier and quadratic Bezier using canvas. This could look cool. So what do I want to do? Instead of having endpoints, I want to have this purple point. So draw point on curve. So tx, ty, dx, c1x, c2x minus y. So it seems like if you have the endpoints, you could calculate c1, p1. Split one quadratic Bezier curve into two. Python quadratic Bezier. Bezier curve. Oh, that's a YouTube video. Python class for creating and optimizing quadratic and cubic Bezier curves. Calculating maximum curvature, calculating points of the curve, calculating the arc length of the curve, adding an obstacle. Oh, that's great. So I think I could just add an obstacle and say don't run into this obstacle. Bezier curve obstacle. I wonder if this has documentation. Bezier curve. Well, that's pretty awesome. So, Bezier curve Python. Oh no, not Python. Bezier curve obstacle. So I guess that's for robotics. So let's see, ob. So I wonder what kind of arguments obstacle takes. Bezier.py. Cubic Bezier. And quadratic Bezier. 3 control points. And then it goes around the obstacles. Oh, so it automatically sets the points to 0. And then you could do random min 0 max 1. So between 0 and 1. Calculate maximal curvature. Calculate curve. Arclan, optimize. Optimizer. How do you add obstacles? Add obstacle. Adds an obstacle to the quadratic Bezier curve. So what's the obstacle to avoid? You could obviously do a set of points or the obstacle to avoid. But, yeah, that doesn't make sense. This is the key, I think. This is what I want. Just have to figure out how to do it. Okay. So, the next step I want to do is figure out how to draw something in Turtle. So let's just say Turtle, Python, draw a function. Okay, I'm gonna turn on some music. I see. So this code, I don't know what that does. Sets up a canvas maybe or something. Set the background color to light blue. Instantiates the turtle object that draws, does the drawing, calls it Fred. Then sc equals turtle does. Then you reset the new screen. You set the coordinates to go to the specific place. That is confusing. Go to okay, and then we could say draw sign of turtle and then screen. Okay, and that should just output the same thing. Just to check. Okay, very good. Now if we want to do a Bezier curve, quadratic Bezier. From Bezier imports quad Bezier. Okay, now we're gonna define a new one. Okay, so we have draw sign. Now there's draw Bezier. With the same arguments. Pretty quiet. The music is okay. So screen.exit on click, draw sign, already have that. Oh man. So we could say my curve is equal to quad Bezier, and then my curve dot random, and then okay, then we could calculate max curve, so my curve dot max k, and then my curve dot calc curve. curve dot calc underscore curve, and then that gives the points. So points equal. Okay, and then that gives us xy points for the curve. So draw side. Actual angle is less than 2. I don't even have to do while. I can just say 4 points. I could say how does this look? Pretty dang good. So, draw Bezier turtle screen and to see how it works, Python initial curve.py well, that could just be an awkward one. Go straight from the there too. That is weird. Snow bringing the debugger. Maybe it's just too small to see the bird. Go to 0.00.01. Maybe that just doesn't work. Maybe. X 0 0 that looks like. And why is that a straight line? That is confusing. I see. Okay, so now what I'm doing here is getting points to draw 0 should be the x coordinates, and we enumerated it so we could get the y coordinate by doing points to draw 1 of c, since c is the count variable. Drawer.go to the x and y point now would look like instead of 0. We're just going to point, and then points to draw of 1. Oh, it's already there. And then index it at C. That should be 0, and that should be, save it. Now I think this should work. Turtle screen over there. Okay, so if we look at len points to draw shape, Okay, so now I have to go look at this guy's stuff and see what's the end points. Which one's the end point and which one's the other point? After I initialize it, obviously. Okay. Oh, that's way too big. plot it. We plot the obstacle. Okay, so that makes sense. That's all in plotting. And this is inside of optimizer. The K optimizer. So that's for finding the shortest route. So it's not going to be in there. Still inside the K optimizer. Now we're inside the L optimizer. I don't know what the difference is, but I'm just using this to optimize the route. Add obstacle. Add random obstacle. Claude Bezier. Plot. So you show the obstacle. Obviously, and you plot Claude Bezier. Optimizer K. Does it just plot the obstacles? Gives you a penalty. Oh, that's we could say if c is equal to 0, so if we're on the first point, which we know we want to meet, and this point we know we want to meet, so if c is equal to 0, points my curve, so not first curve dot points. Okay, so I have to pass in points as an argument. Not first curve dot points. Okay. Points for the second curve. Dot it went back and drew the exact same curve. Oh, because I did points. Drawer.go to my curve.add. So we add those points, points 2 equal to drawer.go to points 2, starting place, point 2, point 2. Okay, cool. So, that one. Let's see how it goes. Wow, great. It's slightly off. I don't know why. Seems like it's going pretty well. Seems like it's just slightly off. That is weird. I could just do it again. Let me try this again, redoing that endpoint. So, do that here. And right before, after code. No, before code. I want to make sure that that point animated two curves to make a shape. Almost works, but it's a little awkward. Oh, one interesting thing to look at before being done is to look at what's it like if it's just totally random. And